Alright guys, so this is still section 5.2 and these are for example under 7. So there's 4 of them. There's an A, B, C, D. So we'll go through each one of them. Okay. And here we're just going to add and subtract expressions. Okay, so kind of like we've done before. These have the same, square root of y and square root of y. So we can just simply add the coefficients. So this is just 11 square root of y. Hopefully that's something that you can already do before this video. Alright, if we look at if we look at B, this is a little more complicated than A. We have to do a little bit of work. Now remember, when we're adding and subtracting, what's on the inside of the radical has to be the same. So as this is right now, we cannot combine these. Okay, so what we need to do is let's take a closer look and let's reduce each one of these. Okay, so let's reduce 12 cubed root of 2z to the 5th, and then let's reduce z times cubed root of 54z squared. Okay, so this reduces to 12z cubed root of z squared. Okay, so cubed root of 2 can't reduce, but cubed root of z to the 5th can. Okay, this one here, let's break down 54 over here. So 2 goes into it 27 times, 3 goes into it 9, 3 goes into 9 3 times, 3, 1, 1, we're done. We're looking for the third root, so we're going to go groups of 3. So this is just 3 cubed root of 2. So this can be simplified to 3z cubed root of 2, and then we're still left with z squared on the inside. Okay. Now, oh, sorry, here's a 2 right here that I forgot. Okay. Now we're looking good because this is cubed root of 2z squared, this is cubed root of 2z squared. So now all we have to do is 12z minus 3z is 9z cubed root of 2z squared. That is your final answer. Alright, I want you to go ahead, try to do C and D on your own. D is really, really simple. C is a little more challenging, so you might want to try to do D first and then C. And then we'll go over this. Alright guys, let's go over C and D now. Okay, C, I'm going to reduce each one of these, or simplify, maybe I should say, each one of these individually. Okay, so when I do this, the only thing I can simplify here is the p to the 6th. So one of those p's would come out and I'd still left with p squared. So this first part here goes to 16p 4th root of 3p squared. Okay, minus, and then I reduce this. The 4th root of 48 is what simplifies here. And as I simplified, I showed it over here. It's just 2 times the 4th root of 3. So 2, our p's still there, 4th root of 3, and then don't forget your p squared still stays there. So after I do that, what I have inside the roots is the same, and so I can just subtract 16p minus 2p, which is 14p, and then keep the root the same. So this would be your answer. Okay, D would be quite a bit simpler. You would just, and you could change this to radical form or this to exponential form. It doesn't matter. I changed them both to exponential form. And what you get is 3 times x to the 3/4 plus 5 times x to the 3/4. So it works out nicely because x to the 3/4 is the same on both sides. So 3 plus 5 is 8. So you're left with 8x to the 3/4. Or if you want to write it in radical form, 8 times the 4th root of x cubed, that would work as well.